When you see a perfect, gleaming bar of gold, you probably think of treasure, right? Or wealth. But what you're really looking at is the grand finale of an incredible, violent, and chemically complex journey. So let's dive into how that gold is really made. Because here's the crazy part. That solid bar begins its life as microscopic particles. We're talking literally invisible dust, locked inside thousands upon thousands of tons of hard rock. So the real question is, how on earth do you turn a mountain into a bar of pure gold? Well, the entire process kicks off with a really simple, almost brutal goal. You have to free that gold from its rock prison. This first stage is all about brute force, pure mechanical power.
First up, you've got these massive chunks of ore straight from the mine, being fed into a primary jaw crusher, which basically just chews them down into smaller rocks. Then, cone crushers take over, breaking those down even more. But the really crucial step happens in the milling circuit. Here, giant sag and ball mills tumble the rock with heavy steel balls, grinding and grinding, until it becomes a fine, watery mud we call a slurry.
And just to put this into perspective, because the scale here is unbelievable, we're starting with rocks about the size of a large grapefruit, and we're grinding them down until the individual particles are just 75 micrometers across. That is finer than a single strand of human hair. It's the only way to make sure those microscopic gold particles are finally exposed. All right, so we've turned a mountain of rock into fine powder. Now for the really clever part, a full-on chemical heist. In this stage, we're actually going to make the solid gold completely disappear into a liquid, only to snatch it right back out again. This first part of the magic trick is called cyanidation. That slurry we made gets pumped into these enormous tanks, and a sodium cyanide solution is added. Now, this chemical is like a magic key that only unlocks gold. It specifically targets the gold particles, dissolving the solid metal and pulling it into the liquid. But, for this to work, the chemistry has to be absolutely perfect. You need just the right amount of cyanide. The pH has to be kept high, around 10.5, which is super important for safety. It stops dangerous gas from forming. And you need tons of dissolved oxygen, which is often pumped right in, because oxygen is what actually makes the whole gold-dissolving reaction happen. Okay, so the gold is now floating around in this liquid, but so is all the useless rock pulp. How do you separate them? Well, this is where the hero of our story comes in. Activated carbon. Think of it as a super sponge for gold. It's got this massive internal surface area with millions of tiny pores that are just perfect for trapping the dissolved gold. This whole process is called adsorption. And this is where the engineering gets really slick. The gold-rich slurry flows through a series of tanks, say from tank 1 to tank 6. But the fresh, hungriest carbon gets added to the last tank and moves in the opposite direction. What does this do? It means the cleanest solution meets the freshest carbon, grabbing every last speck of gold, while the richest solution meets the already loaded carbon. It's just incredibly efficient. All right, our carbon sponges are now totally loaded up with gold. So the next challenge is, how do we get that gold back? It's time to reverse the magic trick and, well, wring out those sponges. This is done using a process with a fancy name, Elution. The gold-loaded carbon is moved into a special column, and a hot, high-pressure, caustic cyanide solution is flushed through it. This powerful chemical cocktail is designed to do one thing: force the gold to let go of the carbon and dissolve back into a new, but this time, highly concentrated liquid. And you can see here, to make the carbon let go of that gold, you have to get pretty aggressive. We're talking temperatures up to 130 degrees Celsius, super high pressure to keep everything liquid, and that potent chemical mix. It is a harsh environment, but it's exactly what's needed to strip that gold clean off the carbon. So, we've done it. We've successfully moved the gold from a huge volume of slurry into a small, super concentrated liquid. But it's still a liquid. The big question is obvious, right? How in the world do we make it solid again? The answer sounds like something out of a sci-fi movie: electrowinning. This gold-rich solution is pumped into special cells that have steel wool cathodes hanging in them. Then they run an electrical current through the liquid. This electricity causes the gold ions to basically snap back into their solid metal form, plating themselves directly onto the steel wool. You're literally using electricity to win the gold back. After electrowinning, what we have is this sludge, a mix of gold, silver, and bits of steel wool. And that brings us to the grand finale. This is the part everyone pictures when they think of making gold, the dramatic, fiery finish where we forge the final bar. So this sludge gets scraped off, dried, and then mixed with chemicals called fluxes, things like borax and silica. This whole concoction gets thrown into a furnace and melted down. The fluxes are kind of like a cleaning agent for molten metal. They grab onto all the leftover impurities and float to the top as a glassy layer called slag, leaving the much, much heavier molten gold and silver to sink right to the bottom. And when we say melted, we are talking serious heat. The furnace gets up to around 1200 degrees Celsius. That's over 2000 degrees Fahrenheit, as hot as lava flowing from a volcano. At that temperature, everything becomes liquid, and gravity can finally do its job and separate the good stuff from the junk. Then, that pure molten metal is poured into molds, creating what's called a doré bar. And as you can see, it's not 100% pure gold just yet. It's usually somewhere between 80 to 95% gold. The rest is mostly silver with a few other trace metals. This bar is the final product from the mine, before it gets shipped off to a specialized refinery for that final push to 99.99% purity.
And there you have it, the whole journey. Just think about that for a second. We went from literally tons and tons of rock holding nothing but invisible dust, through all that crushing, grinding, dissolving, catching, stripping, and smelting to produce a single 25-kilogram bar of nearly pure gold.
So really, the next time you see a piece of gold, whether it's a ring or a coin or a bar in a movie, will you see it a little differently? Will you think about the absolutely incredible industrial, chemical, and physical journey it took to get from being microscopic dust inside a rock to the precious metal right there in front of you?